All right, on page 295, this is 35, and I have to find the quotient, and of course I can't leave the I or the root 2, that whole term, in the denominator. It's not rational. So I need to rationalize the denominator, so I'm going to use the conjugate and multiply by the 6 plus I root 2 by its conjugate of 6 minus I root 2. So I have to do the same thing in the numerator, so I'm multiplying by 1 in the form of conjugate over conjugate. So in the denominator, of course, I'm going to get first term squared, so 6 squared minus the I root 2 squared. So that's going to be a 36 minus squaring. When I square the square root of 2, I get a 2, and then I squared. So I squared is, of course, negative 1. So that's going to come over and change that sign to plus. So 36 plus 2 is a 38. So I'll have a 38 in my denominator. Now in the numerator, I got to FOIL this all out. So, you know, it's 6 minus I root 2 times itself. So first term squared is 36 minus 6I root 2 minus 6I root 2, so minus 12I root 2 plus I root 2 squared. So that's going to be root 2 times root 2 is 2I squared. Now this becomes a negative 1, so this whole term becomes a negative 2. So I have 36 and negative 2 as the real part, so that's a 34 minus 12I root 2 all over 38. Okay, so there's a common factor of 2. That's the greatest common factor that's in all three of the terms, the 34, the 12, and the 38. So and if I pull that out, I get 17 minus 6I root 2 all over 19. So now to put this in A plus BI form, I'll have 17 over 19 is the A plus, okay, so it's minus here, and I'm going to have the 6 and the root 2 together. Those are the real parts, over 19, and then take the I and write it like so. So 7/19 minus 6 root 2/19 times I is in complex form. So that's the quotient in complex form.